Alright, now we are actually going to look at the nuts and bolts of how to do these. So I have 4 radical expressions that I need to simplify. Let's go ahead and take a look. So for this first one, what I have to do is first get the prime factorization of 50. So I'm going to rewrite this as the square root of 50 equals the square root of, and now I'm going to find all the prime factors of 50. So in order to do this, I'm going to take 50 and then I'm going to start dividing by the prime numbers and seeing what works. Well, there's a 2, so I can add a 2 to this. And now I'll try 2 again. Obviously that doesn't work. So our next prime number would be 3. That doesn't work. Our next one would be 5. That does work, and it gives me a result that is prime as well. 5 is a prime number. So we know the square root of 50 is the square root of 2 times 5 times 5. So what we're going to do with that is we're going to take and we're going to look at anything that we have 2 of. The index on this would be 2, so we're looking for pairs of 2, and we have 2 5s right there. So what I'm going to do is I'm going to take that pair and I'm going to move it to the outside of the radical, but when I do that, it's like these 2 smush into 1, so that when I rewrite it, what I'll have is that the square root of 50 is equal to, well, there's just 1 there, so it would be 5. So again, those 2 became just 1 when I pulled it to the outside, and inside the radical, and the radicand, the only thing I have left is the square root of 2. So the square root of 50 is just 5 times the square root of 2, or 5 root 2. Alright, let's do the same thing down here for this one. I'm going to rewrite it in just the same way. But now I'm going to say, since I have this coefficient in front, this is going to be negative 4 times, and now I need the prime factorization of 80. So I take 80 and I divide by 2. Well, that works. Divide that by 2 again. We'll keep using 2 until 2 doesn't work. Divide by 2. And that gives me 10. We can see we can divide that by 2 again, and that's going to give us 5, which is prime. So that is our prime factorization. We have 2 times 2 times 2 times 2 times 5. And so now what we're going to do is just like before. Our index was 2, so we look for anything that comes in groups of 2's. Well, there was one, and there's another. And I'm going to move both of those to the outside. Now when I do that, they combine down into 1. This is like taking the square root of 2 squared would just be 2. So just a 2 moves to the outside. And when I have multiple things move to the outside, I'm going to multiply them all together. So this tells me that negative 4 times the square root of 80 is going to be equal to, I still have that negative 4 on the outside. I may be focusing this a little bit. We still have that negative 4 on the outside, but we also pulled a 2 to the outside, so I'm going to multiply those 2. And I also pulled another 2 to the outside. And then on the inside, the only thing I have left of the radicand is a 5. And so I can now simplify all of this to tidy it up. Negative 4 times 2 times 2 is going to be negative 16 times the square root of 5, just like that. Alright, we can do the same thing. Now I'm hoping you see the pattern for part C. We're just going to rewrite this as its prime factorization. To save some time here, I can tell you the prime factorization of 27 is 3 times 3 times 3, but now notice this k. K to the 4th means k times k times k times k. And just as before, I'm looking for pairs. Well, there's a pair, there's a pair, and there's a pair. And so I'm going to move all of this to the outside. And everything moved to the outside. We're going to multiply together. So I'm going to get negative 3 times 3 times k, and inside the radical, all I have left is a 3. So crunching it all together, I have on the outside negative 9 times k squared, and then on the inside multiplied by the square root of 3. Alright, for our last one, forgive me for this, I'm going to make a last-minute substitution to this. Instead of working this problem, there's a particular type of thing I want you to see. Let's do instead 96 times a squared. You'll see why when we get to it, but there's a particular situation that needs to come up. We're going to rewrite this as its prime factorization. The prime factorization of 96, I'll go ahead and spill the beans, but you can do this with your calculator or however you see fit, is 2 times 2 times 2 times 2 times 2 times 3, and now I also have my a's, and I'm looking for groups of 2 since my index is 2, and I have all of that left. So I'm going to pull all 3 of those groups to the outside. This gives me negative 3 times 2 times 2 times a, and then on the inside all I have left is 2 times 3. 2 times 3 is 6. So let's tidy this up a bit. Negative 3 times 2 would be negative 6. Negative 6 times 2 would be negative 12. So I get negative 12a times the square root of 6. But there's something else going on here. Anytime I pull a variable to the outside, and that variable is to an odd numbered power, it's a to the first, a to the third, a to the fifth, whatever, I have no guarantees that that thing is going to be positive or negative. It's kind of an unclear situation, so to help clear it up, I'm going to say that it's the absolute value of a, because we don't want this thing to be negative, because if we're dealing with a negative something on the inside of there, we're just not going to go there. So we can say that this is going to be negative 12 times the absolute value of a times the square root of 6. So again, that happens when you have a variable raised to an odd power on the outside. Make sure that you put it in absolute value bars. And that's how you simplify radical expressions.